KBYP with more on the mic or more on the mic or however you want to reckon it. Part 2 of the TR3 microphone saga. This thing kicked my hiney again. Bad. Of course, I'm sharing my technical embarrassments with you on YouTube because in engineering and technical and in science things, that's the way it is. We make more mistakes than successes. If it was easy, everybody would do it. But I chased all over you-know-what and back, did the bounce modulator thing, looking for distortion in the transmitter. And I still got reports that it wasn't right. Well, what I found was that the microphone was extremely, horribly overdriving the input. The mic was going over a volt peak to peak. And this mic input needs to be, I measured 68 millivolts, so grossly overloaded. And when that happens, the final tubes fold back. Too much drive, they start drawing grid current. The transmit ALC clamps the bounce modulator amp, and that's the end of it. So it cuts off. So I was operating it way past what the mic drive should have been. And it was operating on that transmit gain as a limit. They couldn't hear me down the street on this thing. And this goes 180 watts CW. They sure ought to be able to hear it, but they couldn't. It wasn't making any power on the meter. Well, what I found is I had to reshape the microphone amps and put in a new mic element. And the odd thing that I found was that the mic amps were clean and clear, even with excessive level. I mean, the level problems is with the RF drive into the finals. But oddly enough, the AM modulator was screwing up the sideband modulation. Very strange, and I found it by accident. I just went probing around and happened to stick a scope probe on the AM modulator, and there was bad clipping. And that AM amplifier is a 2-section 13DE7 run-in common cathode, sort of. It's an odd configuration. If you see the real high grid leak resistor, 22 meg, which is supposed to be 2.2 meg, and the grid leak for 2 and 3 is up on the plate. And I scratched my head over that till I figured out that what that circuit is coupling grid to plate, plate to grid. And that amplifier clips at 45 millivolts, not 68. So for levels that are full for sideband transmit, it's too much for the AM mic amp. And so that amp is flat topping, and that's being coupled back into the sideband mic amp and causing clipping and distortion on sideband. I disconnect that AM modulator, it cleans it up. Really weird problem. So now this radio and this microphone element have a range of about 70 cycles up to 1100 maybe cycles. My voice, there's no way my voice will go across that range. You can hear how low it is. Just worked several QSOs on daytime 40 meter. In the past, they couldn't even hear me. Oh, they hear me now, 10 over. And it is popping on the watt meter. 68 millivolts in from the generator, 150 or a little more on the meter when the mic input is driven by a tone, which makes a steady carrier. In previous videos, especially with the bounce modulator, I showed a waveform at the final grids that had a strange dip in the middle. Like it would come up and then dip down, come back up, and then go down. I didn't know what that was. Well, that was a carrier getting through. So I screwed the carrier in this thing down to 200 cycles below the bottom of the filter. And then I tuned the bounce modulator to cancel the carry out, and man, it's kicking hiney. It works real well. I doubt there's ever been one that worked this well, because they work great in CW and AM, but terrible transmit power on sideband. And everyone I've heard, let's turn the splatter off. Clowns in their power mics, splattering all over heck and back. So with the carrier 200 cycles from the lower peak in the sideband filter, it's got bottom end like you can't believe. I can turn the carrier control a little bit closer, and I can start hearing the 60 cycle leakage from the power supply. So I turned it down to that point and turned it back up to drop that leakage. But this thing is wired and fired, so really no way to fix the AM problem. I'll just have to put some kind of switching in to disconnect the AM modulator and sideband. It doesn't do anything anyway. So hate to do it, but can't have distorted signals. So the other problem here is that very many of us on the air are in our 50s, 60s, 70s, and 80s and have low frequency hearing loss, and low frequencies turn out muddy. And I've gotten complaints even on the ASU from some of the older operators that have admitted having hearing loss. Just had trouble understanding me because it sounds muddy. That's their hearing and they know it. So nothing I can do about that from here. But to be able to cut off the 60 cycle and get away from resonances in the room, echoing from the walls and the mic case, I'm going to get an equalizer. But I didn't want to do that until I had the radio working correctly, and now it is. So that'll be handy for all these phone rigs. And I'll probably go to an electret element, which are pretty flat passband. So note on that microphone, that's for a Drake TR7. It'll put out well over a volt peak to peak. And I took the mic cartridge out. It's in a pod with 2 pins on the back. Take it out of the pod, pry it off, and destroyed the mic element. They glued that thing in, and I pulled the back casing off and just ripped the little 40 gauge wires right off the speaker, the voice cone. So that's toast. But I couldn't use it anyway, and just happens that Motorola was the same kind of cartridge, just with a lot less inductance and a lot less impedance and the correct signal level. So even with a lower output, the 68 millivolt from the generator was about here at 9 o'clock. I've got it turned up just a hair. So there's the answer for poor performance from the TR3 and TR4 on sideband, but it was, I went through 4 or 3 hockey sticks to get there. Okay, BYP.